Hello, I welcome you all to this another interesting screencast, and the video reads uh, locate, or the problem reads locate the centroid Y bar of the shaded area. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have been asked to find Y bar, which is the centroid of the shaded area. A brief background of what centroid is. Centroid is the geometric center. Okay, so you can have centroids. Centroids of lines, or centroids of a line. You can have centroid. Centroid of an area. Centroid of an area. You can have centroid of a volume, right? And if density rho is constant or uniform in a given material, then centroid of that particular body coincides with the center of mass. And if the acceleration due to gravity is also uniform, okay, or the gravitational field is uniform, all right, if the gravitational field is uniform where that body is, then you expect centroid to coincides with the center of gravity. So we need to have an understanding of centroids, because we always use centroids in our analysis of structures. You want to know where the equivalent force, let's say of a distributed load, is located on a structure, okay, and so on and so forth. So that's one of the reasons why we need to have an understanding of centroids. I hope this brief summary was helpful. So having said that, let's dive into the problem. So we are being asked to find the Y bar, okay, the Y bar along the Y, like so, okay. What's the distance if this is our reference here? Well, where do you think along the y-axis we're going to have the centroid? In this area? Is it here? Is it here? Is it here? We need to calculate that point. All right. So let's try and cut a small section. We are going to try sections, vertical cutting and horizontal. Okay. So let's try the horizontal again. You can start with whichever and check which one gives you the simpler equation, because we want to work with a simpler equation after we formulated it, right? So imagine we have this cut, and we are calling this particular cut that we've done, this small rectangular piece, as our dy, because we are along the y-axis. All right, and it is centroidal axis for this small cut. We are calling y, with a curved line, is equal to y. Okay, and then let's call this distance from here to there as our x. Okay, because this part keeps on changing, right? This slip as it moves from 0 to h, it keeps on changing. So as it moves from 0 to h, the x will keep on changing. So we are calling that one x, and if we did so, then this whole length of this strip, we are going to call it as a minus x, right? Is that fine? Great. And if this is the case, what is the centroid of this small piece in the x direction? So in the x direction, therefore, is going to be equal to, this is what we want to find. It's going to be equal to, let's find that together. So what do you think is going to be? I know you know it already. What are you saying? I've gotten you. That's the answer. That's the very thing I want to do here. And I'm trying to draw better lines. Something like so. So like you said, if I got you clearly, you are saying, so our x squared will be equal to x, right? Then plus what? Plus a minus x over 2, right? But we can simplify this further, right? And if we simplify it further, this to simplify it, what does it become? I think this has chewed a little bit of my space. I do not want this to chew a lot of my space. Let me put it like so. So we have x squared is equal to x plus a minus x over 2. If we simplify this further, what does it become? If you simplify this, then it becomes just equal to, it becomes equal to x plus a, right? Because if you make if you put a 2 there, then over 2, right, then that becomes 2x minus x, which is just x then plus a, right? See what I've done? Great. So this becomes x plus a divided by 2. Is that fine? Yes, great. All right, now let's find the small area for this particular strip. Very, very small strip. Let's find this small area also. All right, so we are calling that small area as our dA, which will be equal to, what's this length, horizontal length, is a minus x. Great. And what is this vertical length or vertical height? Is a dy, right? So this is the area. All right, so if we integrated this, then we can find the area for everything, right? Great. If we did an integral of this, okay, then we'd find the whole area, right? Great. So that is the area. And what's our equation that governs that line? We've been told is y is equal to h divided by a to the power n times xn. Great, great. All right, so it means we need to write this in terms of x. So if we wrote it in terms of x, what do we have? All right, it will be x n is equal to a n divided by h times y, and therefore our x will be equal to, just getting the positive, this n we don't know what it is. It can be positive or negative, so it can, it can be even or odd, rather, sorry. This n is, so it can be even or odd number. So this equation therefore becomes equal to a n over h y, everything to the power 1 over n, right? So this is the expression, and we know the equation for finding the y bar. We are taking what are called moments of area, right? Moments of area. So we are equating the two and then making y bar subject to the formula. Basically, that's what we are doing. So integral of the centroid axis of that small strip, okay, dA divided by integral of just the area. We just want the area there, right? Great. So if we expanded this further, we know our y bar. Our y bar is just our y curled is just y, right? Just y, and our dA we said it is a minus x, then dy like so, then divided by a minus x, okay, dy. All right. Okay, so look at this. So now we need to replace. We've seen this x because since we are integrating using the y constants, okay, the y integration constants, but we've not been given, right, in this problem. We only have we, no, we have, it's from 0, we've been given, sorry, we've been given is from 0 to h, and then here 0 to h. Okay, so now we need to replace this value here, this one here, right? Okay, but already this brings about a lot of complications. For me, I would not want to choose this. Not that it is not going to give us the solution. It can give us the solution, but I feel there is maybe a lot of work. I don't know. Let's write it. What do you think? We can write it and see how it comes out. So we have y bar equal to integral from 0 to h y, then a minus an divided by h times y to the power 1 over n. Well, it's doable. If you wanted to, it's doable, but I feel maybe there is a lot of work here for me. It's doable and so on. Okay, dy divided by integral 0 to h a minus x dy. Right, we can go ahead and work it out. Okay, because at the end of the day, if you're integrating with respect to y, then all the variables need to be y in there, right? If you're integrating with respect to x, all the variables in there needs to be x. I mean x. So the this one at the very end determines the variables, right? If it's to y, all the variables are supposed to be replaced and changed to y and so on. So for me, I think I'll not go for this one. I'll not go for this one, but if you want to, we can continue with this one. Okay, so this is the expression that we have, and I'll leave it the way it is. Then I want us to look at that other one, and then we compare which of the two it looks easier. Okay, so, and with experience, you don't even need to do this. You can just, just looking at the problem to say this one, unless the problem specifies to say you just have to integrate with respect to dy or dx. If they specify, then you don't have a choice. But if they don't, then you choose which one to use yourself. All right. Of course, you can change because you have y, h, nx dn. Okay, if you want to, you can as well change the dy there and so on. Okay, and change the integration, because you can rewrite this, writing the function, and this gives us h a n, and then you have n like so. Okay, then x n minus 1, right? Okay, that's the first derivative, right? Which you can write as dy is equal to h a n n x n minus 1 dx, right? Let's say you wanted to use the same and then you just want to change things and so on. You can replace this one there Okay, once you replace that one there, dx, of course, you need to change the integration constants. Then you change all the variables in there to x, right? You can do all this stuff and so on. It's up to you, right? Okay, so now let's try the other one. We see whether it's giving us something. Let's work. Again, it's up to you to pick whichever is favorable. Let's make a section along this direction like this. This is our dx, and then we have this one is going to be equal to our x centroid or distance or location, which is just going to be equal to x. This whole length here we are saying is y, and our centroid or position, this one there, is going to be equal to what is this? This is y curled. This is y curled. Now let me not chew a lot of space, because space for me is very cardinal. All right, so this one is y curled, then y over 2. Right, this one looks very promising, right? What do you think? Anyways, we have our dA. Our dA is equal to y, right? Y what? Y dx. Great. And then our y bar, if we wrote the equation, becomes equal to our y. We are looking for y bar, right? Our y bar, okay, is equal to integral of, the equation doesn't change, right? It remains the same. Integral of y curled dA divided by the total area, okay? And our y curled is what? And is y over 2, right? And our dA is what? Is y dx, okay? Divided by integral of y dx. So since we are integrating with respect to x, so our integration constants will change. They will be from 0 to a and 0 to a. Okay, it's very important never to forget that. And finally, our y bar is going to be equal to 0 to a, 0 to a, the y squared to multiply, then we can factor out the 2 outside there, then we'll have y squared dx divided by 0 to a just y dx. Okay, so if we went ahead and did the integration, if we went ahead, of course, let's look at the two equations before we move on. Let's look at the two equations. We have this equation 0 to a y squared dx, and integral from 0 to a 0 to a y dx. Which of the two equations you think is a little bit direct? Which one between equation 1 and 2? Which one would you use? Imagine you just came across, you have two options, and then they just ask you pick one. Okay, which will make you arrive faster to your destination, which is y bar. Which one would you pick? It's 2, number 2. Of course, number 2. I think number 2. I don't know. Number 2 for me, I would pick number 2. So if that is the case, then let's remove this one. But they all make us arrive at the same destination. Only that one may take a little bit what? Longer. Great. So let's wrap this one. We wrap this one. We go with the first one. Not that there is something wrong with that one. There isn't anything wrong. It's only that it takes a little bit longer. Great. So if this is the case, then let's work with this one. All right. So y bar therefore is going to be equal to 1 over 2 integral from 0 to a. What is our y squared? we've been given our equation. What is our equation? Our equation is y is equal to, this is the equation here. All right, this is the equation. So we need to replace this equation where? We need to replace this equation here. We replace it here, and we also replace it where? Here, right? Of course. So we need to replace it. So if we did so, let's write it, let's do the replacement, then it becomes what? It becomes h divided by a to the power n, and then x to the power n, everything squared dx. Great. And then we do the same also at the bottom there, like so. X and dx. Great. So then I think this one is much faster to make us arrive to the destination quickly. Will it? I think so. What do you think? It will. So if we did the multiplication up there and so on, we'll have 1 over 2. All right. What do we have there? Of course, we can factor out these other guys, the constants, right? So it's h divided by h squared divided by 2an to n, right? Because there's a squared there, right? Then integral from a to this, then we have x to the power 2n, okay, dx, okay, divided by integral from, also we factor out there, we just have h divided by a to the power n, and then inside we have just x to the power n dx. So if we integrated that, then of course one part of this cancels, h cancels there, and then our n there will just remain with one n. I mean a to the power n, just one. So we'll have h divided by 2a, like so, right? And then on top there, if we did the integration, we're going to have something like this is x 2n plus 1, right, divided by 2n plus 1, okay, integrating from 0 to a, divided by x n plus 1 to the power x plus 1, divided by n plus 1, 0 to a. Okay, so if we simplified this, we are going to have the following expression: y bar is going to be equal to, on top here, this becomes h 2n, like so, to the power n. Then there we'll have n to the power 2n plus 1, okay, 2n plus 1, there's a division there, n 2n plus 1 divided by 2n plus 1, like that. And then at the bottom we have a n plus 1, then divided by 2n plus 1, right? Okay, so if we further simplify this, then we are going to have y bar is equal to, further simplification, an, okay, can subtract, then we'll have h, like so. Then we have a to n plus 1 minus n, okay, divided by 2n plus 1, okay, and then we have just a n plus 1 divided by, I mean a to the power n plus 1, then 2n plus 1, okay. Then y bar eventually gets to, then y bar eventually becomes equal to h divided by 2. We have 2n minus n is just a to the power n plus 1 divided by 2n plus 1. Okay, and then n plus 1 divided by 2n plus 1. All right, so this and this goes. What do we have finally? We have this one is which one was n? Sorry, this one is supposed to be n. This here is at the bottom here is n plus 1, right? Here is n plus 1, right? At the bottom it is n plus 1. This is n plus 1 there. This is n plus 1. Great. Of course. Like so. And then once we've done that, now then we can simplify this further. And if we did so, this can go up if we multiply it by n both sides by n plus 1 by n plus 1. We did the multiplication. This and this goes. Then we have everything on top there. Then this becomes h n plus 1, right? Divided by 2, right? 2, then in brackets 2n plus 1. Yes, this is the final solution. This is the final solution, right? Yeah, it's the final solution. Okay, I think this is about it, and I hope the video was helpful. If it was, give me a thumbs up, like my video, and continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.